So look at figure 1 and figure 2. Now the electron moves along a path like this. The electric field exists into the whiteboard. I mentioned that. Now then, like if I place an electron like this, and this is the positively charged plate and negatively charged plate, the electron is attracted to the positively charged plate. Can you see the electric field exists from the positively charged plate to the negatively charged plate? And the direction of the electric field is opposite to the direction of the force on the electron. Right, very important. Direction of the force on the electron is opposite to the direction of the electric field. So then, can you see this? Like the electric field exists into the whiteboard, then the electric force should be existing out the whiteboard, right? Electric force should be existing out of the whiteboard because the electric field is what? Into the whiteboard. Is that clear? So I marked that here. Then the magnetic force should be existing what? Where should it be existing? The electric force is occurring outwardly. Therefore, the magnetic force should be occurring into the whiteboard. Otherwise, the electron cannot follow a path like this in the x direction. Outward force should be cancelled off by what? The total inward force, right? Okay, now you can understand that. Now, look at this. Now, there's a funny way to get the answer very quickly. And this is very useful in certain questions, like instead of using the Fermi's law, right? Now I'll just teach you that something extra because you can refer Fleming's law obviously from books, right? Okay. Now, what does it normally say now? If I have a current like I like this, if you use my technique, if the current is going like this, I learned it from somewhere, I can't really remember where, right? So I just feel as if I found it, I don't know, I can't remember. So if the current I goes like this, right, and if the magnetic field exists into the whiteboard, then the force on the charge plus Q is occurring upwards. Force is upwards. The current is occurring like this, therefore my fingers show the direction of what? The movement of what? The current. My palm feels that the magnetic field lines are cutting, right? My palm feels like the magnetic field lines are cutting. Then the magnetic force is upwards, F. Now, in this instance now, okay, let's see. Consider an instance like this. The magnetic force is occurring outwards and the current is occurring in this direction. Suppose, just suppose, right? For example, the current is occurring in this direction. Therefore, my fingers show the movement of current. But the magnetic force is occurring what? Into the whiteboard. The magnetic force is occurring into the whiteboard. The current is going in this direction, to the right, right? Then my palm feels as if the magnetic field lines are cutting through like this. Therefore, magnetic field is existing downwards. Here, the magnetic field is existing what? Downwards, B. Now, if I reverse the direction of the current, what's going to happen? Same force, but I'm going to reverse the direction of the current. What's going to happen? Then the magnetic field exists upwards, right? Now see, same logic can be applied here. Can you see the magnetic force is existing into the whiteboard? The magnetic force is the magnetic field is existing into the whiteboard. Magnetic field is existing into, magnetic force is existing, magnetic force is existing into the whiteboard and the current is going in the direction to the left, then the magnetic field should be occurring upwards. So you guys get this technique, right? So then the answer is matching, like second one and the first one for now, right? Second one and the first one for now, but then we have to consider this path as well. Let's see. Now listen, now why did I say the current to be in this direction? Now when the electron moves to the right, we say the current moves to the left because the direction of current is the direction of movement of the positively charged particle, right? If the electron moves to the right, then the current is moving to the left. That's why I consider the current to be to the left here in this occurrence, right? And the force is occurring into the whiteboard. Therefore, the magnetic field is occurring upwards, right? Region 2, right? Let's see. Now this electron experiences a centripetal force inside, like this, right? So you can see the direction of the centripetal force and therefore the velocity. What's the direction of the current then? Downwards, right? Current is downwards, no? Current is occurring downwards, current downwards. And the force, the current is downwards, and the force in the, now suppose current is occurring downwards. Current is occurring downwards, and suppose the force is in this direction. Current is occurring downwards, and the force is in this direction. Then the magnetic field exists into the whiteboard, right? If the current exists downwards like this, and the force exists down in this direction, then the magnetic field is occurring into the whiteboard, right? But now the force is in this direction. I'm reversing the force. Therefore, the current is also downwards. It doesn't change. Current is downwards. Force is in this direction. Then magnetic field should be occurring in what? Out of the whiteboard. Therefore, it should be a dot. Is that clear?